Yeah, welcome everybody. I'm going to be talking about specifically Async I/O and type hints, two of the big header features that got added to the Python Elasticsearch client in the past year. So I'm Seth, software engineer at Elastic. My handle on GitHub and Twitter, if you need to get a hold of me, is at Seth M. Larson. So I've been at Elastic for like almost a year now, and these are like two of the most exciting features that have been added to the Elasticsearch client, which is one of my main jobs here at Elastic. I do a couple other Python flavored things, but that's the one that I spend probably the most time on. So these are just logistics. Probably already covered these, so I might just skip this slide pretty quickly. Basically just ask questions in the chat, we'll get to them, and there'll be plenty of time after the entire webinar to answer any questions. Doesn't have to be just about Async I/O or typing. If you have a question about anything related to Python and Elastic, I'll probably be able to answer it. Okay, so what's been happening in the Python Elasticsearch client? So we typically make a release every time that Elasticsearch makes a release, adding the new APIs that have been added. So on the same day that you would be able to upgrade to the latest Elasticsearch, you'd be able to just upgrade your Elasticsearch Python client and use those new APIs. We want to make sure that that experience is really seamless. But then in addition to those like new APIs, we also upgrade new features that aren't API related. So things like Exopack ID for tracing long-running requests in your logs, Elasticsearch warnings. There's this feature in Elasticsearch where Elasticsearch will tell you when you're using a deprecated API. And so if you're using that API, previously you weren't getting anything in the Python space to say that, hey, I was using a deprecated API. And now what we do by default is we actually raise a warning that shows, here's the API that you're using with these parameters. Maybe you should switch to a different API. So that's kind of giving you visibility into how to fix your application without having like breaking changes essentially. Yeah, so basically having people migrate over to these new APIs so that they don't receive that one-day breakage of, okay, all those deprecated APIs got removed. So that's a really popular feature. And then the two that I'm going to be talking about today, Async I/O and type hints, were added just recently in 7.8 and 7.10. So we're going to deep dive into both of those. So if you're kind of wondering, like after this webinar, I just learned a couple of things about Python specifically, because we're going to be talking about some newer features in Python. You can actually look at the source code for the Python Elasticsearch client. It's completely open source. It's under Apache 2.0 on GitHub. And then there's also a lot of extra documentation on these features on Read the Docs. It's just under elasticsearch-py is the project name. So the first one we'll be talking about is Async I/O. So I'm going to start by kind of describing pretty simply what Async I/O is. Async I/O is kind of like cooperative multitasking. It's a way to do more than one task at the same time efficiently. So I made this graphic that's, it's a little complex, but basically what the gist of it is when you're running a workload, if there's I/O, so like reading from a file or talking to a website, all of these things take a lot longer than individual CPU instructions. And so if you're able to, instead of waiting for the I/O to complete before you move on to the next task, if instead you can say, okay, I just scheduled that I/O and now I'm going to go work on something else while that I/O is doing its thing. Because what ends up happening is you schedule the I/O to happen, and then the operating system will tell the I/O when it's complete, hey, I'm done. Now this result can be harvested and then used. If you kind of work around that, you can essentially have your CPU with one worker working on the CPU tasks while the I/O is happening in the background. And so I kind of have this comparison to Async I/O being cooperative multitasking with a single worker and tasks that pause on blocking operations such as I/O. And if you compare that to threading, where you have many workers and you're kind of relying on the operating system to handle that like blocking I/O. So basically in a threading model, when I/O happens, you're relying on your CPU to deschedule that process and then start a new one. And so instead of relying on the CPU, which has no idea of anything related to your program structure beyond like what the instructions are themselves. Instead of relying on your CPU to make those guesses, you are explicitly saying, here are the places where IO can happen. And I know when the IO happens, I'm going to pause my task and switch to something else that I can do. So that's the difference between async IO and threading. So in an IO bound workload, such as like when you're on a web server or you're talking to a database, or Elasticsearch, for instance, is an IO bound typically. Async IO works really great because you're doing so many of these IO operations and there's not as much CPU work to do. And so instead of basically having tons of threads open, which are a lot more resource intensive, you have a single thread open, and then you use IO a lot more efficiently, which this allows you to scale a lot more efficiently if you have an IO bound workload. Okay, so why would you want to add async IO to Elasticsearch? Obviously, the IO bound is great, but the big one is if any program wanted to use the Elasticsearch Python client, but also had async IO, without this special support, it wouldn't be able to do that. So any blocking IO will just completely ruin your performance if you use it in an async context, because you're using, essentially you're using a blocking IO socket, but then it doesn't tell the async task that, hey, I'm not going to be, like, you can stop, you can pause the task. Instead of saying pause the task, it basically just says, I'm going to wait. And so then your entire program grinds to a halt. So basically what ends up happening is to do anything with async IO, you need to have all of your dependencies know what async IO is and implement it. And so with these rising popularity of a lot of async IO Python web frameworks like Fast API, Django 3.1 added async views. Quart is another one that I know of. These are really getting popular. And so if you want to use Elasticsearch from one of those Python web frameworks, you would need to use the async version of Elasticsearch-py. Otherwise, you're just going to get terrible performance. And the other really big thing is Elasticsearch-py is actually a dependency of many packages, both internal and external. Elasticsearch DSL is a really popular package, especially with web frameworks. And so we've had a feature request to add async IO. The first building block on that would be to add it to the base Elasticsearch-py. And now that it's added to the base Elasticsearch-py, we can actually add it to Elasticsearch DSL. And Rally, which is like a performance tool that we use for Elasticsearch, also uses async IO for performance. And they actually supported async IO before we did, just because they really needed it for performance reasons. Okay, so obviously async IO in Elasticsearch is a thing. Came out with 7.8, and it requires you to be on Python 3.6 or above because it uses the async and await keywords. Those are new keywords that were added in Python 3.6. And for an HTTP client library, we use AIO HTTP. So that command that you can see there, that's kind of the suggested way of how to install the async, all the dependencies that async Elasticsearch would need. Essentially that the square braces on the end with async, that's just an extra, which essentially just tells pip to, hey, you should also install AIO HTTP. And then the new API, the top level API, is called Async Elasticsearch. And this is exactly the same as the synchronous client. It just adds async variants of all of the APIs and makes it so that you can use it with these new version of the async helpers. And so we previously had a package that kind of supported async IO, but it was essentially kind of, it was like sitting in the middle between the transport layer and Elasticsearch, and then just wrapping whatever came out of the transport in a future, like an async coroutine, and then returning it blindly. And so this new way is essentially like the full native way to do async versus kind of like this more of a hack type of like wrapping the transport layer in that way. So this replaces that old package. If you're using that old package, it'll still work for 6x and it'll probably work for 7x. But going forward, we're going to be recommending you just use the base package Elasticsearch, the async support that's implemented there. Okay, so this is like a visual comparison. Both of these images look very similar, and that's deliberate. You can see on the left side, that's kind of the traditional, what you would expect from synchronous IO using Elasticsearch. You can see the es.search method is just being called, and you get the response back, and then you print out the hints or the hits. And then on the async IO side, you see you just have to change your import to async Elasticsearch, instantiate that one, and then you'll see the await. So the await right before es.search. And really for a lot of the usage, that's the only change that you'll have to make if you're using async IO. It'll just work and you'll get the free performance boost with the IO bound workload if you're using async already. So it's pretty simple to deploy. So how do we implement it? So the Elasticsearch APIs, they're all generated from specifications that we get. We're really lucky as client developers to have specs to generate from. So what basically we ended up doing is extending the generator to create these async APIs in addition to the synchronous APIs. And there's some additional tooling like unasync that we used essentially that guarantees that the two APIs are the same. So essentially what we do is generate the async API and then we generate the synchronous API from the async API to guarantee that everything is the same, the doc strings, the types, everything. So one of the kind of hurdles that we had to get over was these APIs use async await and they would cause syntax errors in earlier Python versions. And so what we do is we keep the async code separate and then we only import it into Python versions that we know support it. Which is Python 3.6 is when async await keywords were added. And so there is kind of like a way that you can support async IO on Python 3.5, but we ended up not going that route just because, one, it's a lot of work for compatibility reasons. And there's this thing called async generators, which are kind of a prickly topic when it comes to that, just because async IO was implemented using generators. And so there's kind of like an interesting relationship there. And then also Python 3.5 really doesn't make up a huge proportion of our user base. A lot of our Python 3 users are on Python 3.6 and later. So there wasn't really a big reason to add it there. And then the code for the transport and HTTP connection, those were all written manually. Those aren't generated. All right, now the second feature, type hints. So type hints in Python, they were released in Python 3.5 with PEP 464, and it's a way to define parameters, return values, and attributes of objects without having to infer those types. So there's these new tools called MyPy and Pyrite, you might have heard of them. You run them on your program, and if your program is type hinted, it will ensure that all of your types work out. So essentially, it kind of gives you the same sort of like check as you would for like a statically typed language like C, but you get it with Python and you don't really impact your runtime. So you don't have to like write code like C, you just hint these like edges of your API essentially, and MyPy for the most part can figure everything else out. The other thing that type hints are really great for is IDEs use them for better autocomplete. So if you have a function and it's generated on runtime, then IDEs don't really know what that function is going to look like because they don't want to execute your code to figure out what your like types are going to be, your function signatures. And so instead of like relying on inferring types, IDEs can check to see if there are type hints. And if there are, it knows exactly what the types and function signatures and skeletons are going to be for your entire API. So that's really a positive experience for people using IDEs. So what are the reasons we shipped them? Well, the big one is function signatures are generated on runtime for Elasticsearch-py. The big one is query parameters specifically are kind of added all at once using a decorator, because there's some of our APIs have maybe 50 plus query string parameters that are all optional. And so rather than having those all be in source code, we kind of have a decorator that makes it a lot more compact. So if you're using an API like search, where it has all of these query parameters and you want to use a query parameter and you start typing that in an IDE, the IDE won't know that that's actually a query parameter because the function signature is generated. And so it's kind of like a negative experience, right? When you're trying to find that query string parameter, it would be nice if the IDE would just kind of show you what it is and then you can hit, tab and it'll auto-complete it. The other nice thing is that IDEs, they have this feature, which I'm showing down here in this picture, that actually tells you when a type isn't right before you even run it. And so this parameter requests timeout. It expects an int or a float, but you're passing in a string in this example. And so it highlights it in yellow and it says, hey, you're supposed to pass in these types, not a string. So this specifically is PyCharm, which is the ID that I use. But there's other IDs like VS Code, and they all do this. And then if you're using MyPy or Pyrite and you give it a library that doesn't have type hints, usually it'll just complain. It'll say, hey, this library, I can't find the type hints for it. Like either find them, install the stubs, you'll have to do some extra work. So instead of having to like have users disable type hints on every time that they import Elasticsearch, they instead will just get type hints, and it's a way better experience. And then you'll actually get those, like the tools will be able to check the types because they won't have to infer anything, and you won't have to disable the type checker. So how do we implement these type hints? So they're new syntax in Python 3.6, and obviously we still support Python 2.7 through 3.5 on Elasticsearch 7.x. So you can see the new syntax here in the picture. You'll see next to index and body, we have a colon along with a type. And then also on the return type, there's an arrow with a type. So that's like showing the individual parameters. This is a string. This is a mapping from body. Mapping for body is a string to anything, and then it returns a mapping of string to anything. And so that is a new syntax. And if you were to import that code in Python 2 or anything before Python 3.6, it would explode and say there's a syntax error. And so how can we support all of those same Python versions, but still ship type hints? So there is a way to do it with comments specifically. Python 2.7 compatible has this comma type where you say type, and then you just kind of rattle off all the types, and then you use the arrow, same thing. But it gets really unwieldy when you have really, really long function signatures, which is the case for Elasticsearch. So you end up having one line that is just super long. And especially if you have like 50 some parameters on there, you just have 50 parameters in that tuple, and you don't know which one really maps to which one. As you can see, they're not in the top picture, the index is string, is very apparent that the index is string. Whereas on the bottom, if you can imagine index string, it's not very close, like location wise. And so it's hard to map between the two, especially if there's a lot. And so that was kind of like a not great option either. And so instead we went with type stubs. So in PEP 561, they defined .pyi files, also known as type stubs. And essentially you can ship those with your package, and instead of being interpreted as Python, only tools and IDEs will use them. And so you can use all of these new syntaxes and new features in the typing module without having to worry that, oh, this is going to turn into an import error when I try to use them in an old Python version. And so these stub files are also generated from the API specs. And that's all I really have on type hints and async IO. Were there any questions that came up?
I haven't seen any, but that doesn't mean there are no questions, so feel free to drop those in. Is there, out of curiosity?
Oh, sorry.
Yeah, out of curiosity, do you have any overview like across what kind of Python versions the Elasticsearch client is used?
Yeah, so actually we track this every time that there's a major release. We wait some time, and then we start checking what Python versions have upgraded so far. So what we see is, I think it's like 15% is Python 2.7, and then Python 3.4 and 3.5 are each like less than 1%. And then every Python 3 version, besides obviously like 3.10 or 3.9, which just came out, is more than 30%. And so that's kind of what we're seeing. And so it's like majority 3.6 and above. We're planning on, or unless like the numbers change by a lot, Elasticsearch version 8 will probably still support Python 2, just because 15%, that's quite a bit. But then, you know, maybe those old Python 3 versions won't be supported just because less than 1%, that's pretty small. And plus they're getting a lot harder to support as well. So we can't use a lot of these fancy new features for Python 3. We have to think about old Python 3 versions.
So we got one more question. Any tips / how to start contributing to the Elasticsearch Pi code base?
Sure. Yeah. So it is kind of a tough code base to contribute to, I would say, just because it's a really mature code base. And so there's not as many like super easy issues, if that makes sense. But if you have some experience with Git, if maybe you've done a contribution anywhere else, I would say just like look at the issue tracker and check out what issues seem interesting to you. One of the biggest, like the tough things about contributing to open source is like the best part is like finding something that's interesting to you. So if you find something that's interesting to you, that's the important part. So yeah, I would look in the issue tracker. There's a good handful of issues in there. There's a whole bunch of Python repos specifically under Elastic. So it doesn't have to be the Python Elasticsearch client. But yeah, just look at issue trackers, find something that's interesting. You can always ask me on Twitter to be like, hey, is this an issue that, would you be able to help me with this issue? Or if you're unsure, you can ask for some questions. I can clarify some things in the GitHub issue. If it's something that you want to try to do, that's definitely awesome. I'm willing to help you. It's part of my job. So just let me know.